Hey, what's up you guys? Thank you for joining me again. Now in today's video, we are going to be covering the second subtopic of chapter 5, which is geometric progression. Now if you haven't watched the first video that I released about arithmetic, please watch that video first before you come to this. Otherwise, it'll be harder for you to understand. So if you have already watched, then you can feel free to proceed with this. Alright, so without further ado, let us get started. Now, before we get into the examples and exercises, let me briefly explain to you what geometric progression is about. So, geometric progression compared to arithmetic. So, what's the difference? The difference is, for example, in the previous video I showed you, arithmetic is when you have common difference. So, for example, let's say you have 2, 4, 6, 8, 10, and so on. Okay, so what's the common difference here? Common difference is D. This thing is called common difference. So the common difference is what? If you take 4 minus 2, you get 2. Or if you take 6 minus 4, you get 2. You take 8 minus 6, also you get 2. So in other words, all of this plus 2, plus 2, plus 2, plus 2, and so on. Okay, it is continuous. You keep adding 2 to get the next term. Alright, what about geometric? Geometric is when you have a sequence that has common ratio. So let me give you an example. Let's say 2, 4, 8, 16, 32, and so on. Okay, so what is needed for geometric progression is this thing called R. R is known as common ratio. Okay, common ratio, how do you find common ratio? It's similar to how you do this common difference, but instead of minus, you divide. So 4 divided by 2, you get 2. 8 divided by 4, also you get 2. 16 divided by 8, you also get 2, and so on. So in other words, the jump, instead of adding 2, now you are multiplying by 2. Multiply by 2, multiply by 2, multiply by 2, and so on. So in other words, arithmetic is when you are adding a number or minus a number. Okay, but geometric is when you multiply or divide. Okay, so that's the difference between arithmetic and geometric. In arithmetic, you want to find for common difference. In geometric, you want to find for common ratio. Okay, so this is the difference. Now, in terms of formula, arithmetic, I showed you all some formulas, right? You have the term formula, you have the sum of terms formula, and so on. But in geometric, you also have that, but you have some additional ones, which I will show you in a short while. Okay, so in geometric progression, there are 4 main formulas that you have to know. The first is the Tn formula. Tn formula for geometric is A, R, n minus 1. Okay, A, R, n minus 1. A is what? A is the first term. Okay, so if for example just now 2, 4, 8, 16, 32, and so on, A value would be 2. What about the R value? R value is 4 divided by 2 equals to 2. Okay, so that is the how you use the formula. Okay, term formula. Next, you have the sum of terms. Okay, Sn. So for geometric progression, you have 2 formulas for Sn. Okay, 2 formulas. The first formula is A Rn minus 1 over R minus 1. Okay, the second formula is almost similar to the first one, but the difference is this: 1 minus Rn, R power n, over 1 minus R. So in what situation do you use the first one, and in what situation do you use the second one? The first one, you only use this when the modulus of R is more than 1. Okay, and if the second one is when the modulus of R is less than 1. Okay, so for example, in this case, you found your R value is 2, correct? So R value modulus R would be 2, correct? So 2 is more than 1. So in that case, you have to use the first formula. What if I have R value equals to, let's say, 0.5? So modulus 0.5 would still be 0.5. So 0.5 is less than 1. So in this case, you use the second formula. However, what if you get R value? What if you get R value equals to -2? Are you going to use the second formula? Answer is no. Why? Because the key thing is they are using here modulus. Modulus means what? Modulus means whatever R value you get, turn it into a positive. Okay, even if it's a negative, turn it into a positive. So a modulus R from -2 will become 2. So 2 is more than 1. So in that case, you have to use the first formula. Alright, so this is basically the difference in terms of the sum of root formula for geometric progression. Now, there is one special formula specifically for geometric, and that is called, the third one here, we call it as sum of infinity. So this is when, for example, you have, this is the sequence, right? 2, 4, 8, 16, 32, and let's say this sequence doesn't stop. It just keeps going until infinity. So the question will ask you, what is the sum of all the numbers? So that is what we use as sum of infinity. So what's the formula? The formula is A 1 minus R. Okay, 1 minus R. Make sure it's almost similar to sum of formula, but you don't have this. Okay, it's just A divided by 1 minus R. So these would be the 4 main formulas that you have to know for geometric progression. So if you understand this, let us go through the examples where you will understand how to apply all these formulas even better. Okay, determine whether the following sequence is a geometric progression. Justify your answer. So they want you to prove that it is geometric progression. So like I said, in order for you to prove, you need to prove that it has common ratio. Okay, so arithmetic, you need to prove that they have common difference, but for geometric, you have to prove that they have common ratio. So question A, how do you find the common ratio? So R1 would be equal to, for example, so R1 would be equals to 40 over 120. Answer is 1/3. Okay, what about R2? If I take 40 over 3 divided by 40, okay, the third term divided by the second term, what do I get? You should also get 1/3. Okay, you can just type in your calculator. So since R1 is equals to R2, right, that means they have what? They have common ratio. So therefore, this is a geometric progression. Okay, geometric progression. Question B. First term is 0.03, then 0.003, then 0.0003. So first we find the first common ratio. 0.003 divided by 0.03. You should get 0.1. What about R2? R2 is 0.0003 divided by 0.003. Answer is also 0.1. So since R1 is equals to R2, this sequence is a geometric progression. Okay, so that is how you prove that it is geometric progression. However, since there is no question like this here, but if in case you do find a sequence that has R1 that is not equals to R2, if it's not, then you can say that it doesn't fulfill, it is not a geometric progression. Okay, so that's how you solve this kind of question. Alright, next. The diagram on the right shows a ball bouncing on the floor. The maximum height of the bounce of the ball is 3 meters, okay, and the height of each bounce is 95% of the previous bounce. From which bounce onwards will the height be less than 1 meter? So the first bounce is going to be, here the highest point is 3 meters. correct? So this is the first sequence, 3 meters. And then the second bounce is going to be 95% of the 3 meters, correct? And then this one, the next bounce, is going to be another 95% of the previous bounce, correct? So what do you understand from here? You understand that the first one, the highest, is 3 meters. So A is equals to 3 meters. Okay, that's the first term of the sequence. And then every subsequent term, you basically have to times 0.95, correct? 95%. So 95%, that means the ratio, common ratio would be 95 over 100, or equals to 0.95. Because why? You're multiplying 0.95 to the previous bounce, the height of the previous bounce. So in other words, every ratio, common ratio, is 0.95. Okay, so that's, if you understand this, you should be able to solve. So now the question is asking you, from which bounce onwards will the height be less than 1 meter? So in other words, Tn, they want to know at which term the value is less than 1 meter. At which bounce, that means at which term the bounce is less than 1 meter. So we are going to use the Tn formula. So Tn is what? You already know that Tn equals to AR power n minus 1. So A is what? A is 3, R is 0.95, n you don't know, minus 1 should be less than 1 meter. Okay, so I'm going to shift the 3 first. So 0.95 n minus 1 less than 1 over 3. So now, I've already taught you guys this in the previous chapter. When you have an unknown at the power, okay, the only way for you to solve is to make the base the same. That means make this 0.95 and this 1 over 3, make them become the same base so that you can compare the power. And there's one way for you to do that, which is basically indices we learned in the previous chapter, right, to make it the same. But in this case, 0.95 and 1 over 3 is a bit hard to make it the same, correct? So the only way, the other way that we can use to solve is by adding log. So log 0.95, see the power is n minus 1, correct? The n minus 1, I can bring it forward. So n minus 1 comes here. Now if you don't understand what I'm doing, if you just have no idea what I'm doing here, right, please watch the chapter 4, okay? I've covered indices and log, okay? So now, I bring the n minus 1 forward, less than log 1 over 3. Okay, so in other words, I'm adding log here, and I'm adding log here. Okay, and the n minus 1, I bring it forward. Okay, so that's the rule here. You can apply this. So now, once you've done this, you can shift the 0.95 to the opposite side. But one thing you notice is that if you key in log 0.95 into your calculator, you will get a negative value. Okay, you get a negative value. And if you shift a negative value, what will happen to the sign? The inequality. The inequality will change sign. Okay, so this one you should have learned in form 2, form 3, I guess. So when you shift this, you should change the sign. So n minus 1 is more than log 1 over 3 divided by log 0.95. Okay, if you key in into your calculator, remember it's a negative value. So negative value, if you bring the other side, you must change the direction of the sign. So in this case, n minus 1 should be more than 21.42. Okay, key in your calculator. Now let me bring this up here. N should be more than 21.42 plus 1 is 22.42. So since n is more than 22.42, in other words, we can say n is approximately 23. On the 23rd bounce is when the height of the ball will be less than 1 meter. Okay, so this is your answer. Find the sum of each of the following. So they want to find the sum of terms. Okay, so question A, they want you to find, see, they already told you that the total is T12, correct? So that means there are a total of 12 terms. So you want to find the sum of all 12 terms. But before that, what's the A value? A value is 0.02. R value is 0.04 divided by 0.02. Answer is 2. Okay, so now you can use the sum of term formula. So R, in this case, modulus R is more than 1, correct? So therefore, you can use the first formula of the sum of term. So A times R is 2 power, see, the n value is 12, correct? So I should write here 12. Then here power 12 minus 1 over 2 minus 1. Okay, so you should get, you just key into your calculator, you should get 81.9. So this is sum of all the 12 terms. Alright, next question B. They gave you, now this one they didn't give you any numbers, right? They only gave you unknown, which is the P value. Okay, but it's okay, we still can solve this. You know what's the A value? A value is P, and the R value is P cubed divided by P, which is P square. Okay, so you got A value and R value. Problem is, you cannot straight away use the formula because you don't know how many terms are there. Okay, but you do know one thing. You do know that the last term is P12. So we want to know how many terms are there. So we have to start with this. Tn is equals to P21. We want to find out when the term value is P21, what's the value of n? That's what we want to find out. So use the Tn formula. Tn, what's the Tn formula? A R n minus 1, correct? So A is P value, R is P square, n minus 1, sorry, equals to P21. So now I'm going to break this down. It becomes P times P power 2n dot means what? Dot means times, okay? Dot P power negative 2 equals to P power 21. So in this case, I'm going to combine these two. What you will get is P power 2n times P over P square. Remember, P negative 2 is the same as 1 over P square. The negative means fraction. Okay, so in this case, it becomes P over P square. So here you can simplify, becomes over P. So P power 2n is equals to, the P here I can bring forward, correct? So I should get P power 22. So in other words, what can you say? 2n is equals to 22. So therefore, I'm just going to write here, n should be equals to 11. Okay, so in other words, in this sequence, you have 11 terms. So now you want to find the sum of all the terms. So now you can use your Sn formula. So Sn equals to A power Rn minus 1 over R minus 1. So what is A? A is P value. R is P square. And then your n value, okay, n value has to change because now you already know your n value. N value is 11. So P, this one is times 11 minus 1 over P square minus 1. Okay, so P, and then you times here, you should get P power 22 minus 1 over P square minus 1. Okay, so this should be your answer. Okay, you want to expand it, it's up to you, but this is the most simplified answer. Alright, next. A squared paper is cut into 4 equal size squares. Each portion is then cut into 4 smaller equal size portions. This process is repeated on each of the small portion square. Show that the number of squares cut forms a geometric progression. So first thing, they want to see the number of squares, correct? So we're going to follow the sequence first. What's your sequence? First you have one piece of paper, correct? A square paper. So there's only one square, correct? Next, you're going to cut this into 4. So that means your second sequence here, you have 4 pieces now. right? You got 4 pieces of square, so here is 4 pieces. And the following one, you're going to cut them into another 4, each of them, correct? So you're going to have how many pieces now? You're going to have 16, because each one will have 4. Here I have another 4. Here we have another 4. And here we have another 4. Okay, so total you have 16. So the sequence will continue. Okay, it goes on like this. So now you already form your sequence. They want you to show that question A, it's a geometric progression. So geometric progression means what? R1 is equals to 4 divided by 1. In this case is 4. What about R2? 16 divided by 4 equals to 4. Correct? So in other words, R1 equals to R2. Therefore, this sequence is the number of squares. Number of squares cut forms a geometric progression. Okay, so this is the you have managed to prove. Okay, question B. Question B is what? Find the total squares. Total squares. So they want to know all the squares obtained if the process is repeated for 6 times. So they don't want you to find the Tn. They want you to find everything, total number of squares. So you have to use the Sn formula. Okay, sum of terms. So the first term is 1. That means you got 1 square, 4 square, then 16. So now you want to find the sum of the terms when it is repeated for 6 times. So now your Sn becomes S6. Okay, sum of the 6 terms. So in this case, are you going to use the first formula or the second formula of the sum of term? You're going to use the first one. So A Rn minus 1 over R minus 1. A is what? A is supposed to be 1. So 1. So because here's the first term, right? So A is 1. So 1 times R is 4 power 6 minus 1 over 4 minus 1. Okay, you key this into your calculator, you should get 1365 squares. So that's the total number of squares if the process is repeated 6 times. 4.818181 can be written in the form of h over 11. Find the value of h. So in this case, what you notice is that it's an infinitive number, correct? Decimal place. So because you notice they have the dot here, so that means the 818181 is not going to stop. So it's going to be 4.8181818181 until you don't know when. Okay, you don't know when it's going to stop. So from here you kind of have a hint of what they want, what they want you to do. Because it's a non-stop decimal place, you can use the sum of infinity formula. So in this case, they want you to change in the form of h over 11, in the form of fraction. So let us do it together. 4.818181 is equals to what? 4 plus 0.81 plus 0.0081 plus 0.000081 and so on. Okay, so the reason why I took this out is because 4 is not a recurring number. Okay, so I leave it by itself first, but the recurring one is this part. Because why? It's going to be 818181 and non-stop. So this would be the sum of infinity. Sum of infinity. Okay, because you're going to add them up, correct? So in this case, 4 plus sum of infinity. Okay, so what is the sum of infinity? The formula is a over 1 minus r. So in this case, what is the a value? A value is the first number here, which is 0.81. What about the common ratio? Common ratio is 0.0081 divided by 0.81. Answer should be 0.01. Okay, so you found your a and your r value. Now you can solve. So 4 plus a is 0.81 divided by 1 minus 0.01. So 4 plus 0.81 divided by 0.99. So to change this into a proper fraction, you can first times 100 here, times 100. You get 4 plus 81 over 99. Then you can divide by 9, divide by 9. Answer is 4 plus 9 times 9, 9 times 11. Okay, so this one, you become what? 4, 9 over 11, correct? You can change it into an improper fraction. So you get 53 over 11. So this is equivalent to what? H over 11, correct? Because they want you to compare in this form. So in other words, H is equals to 53. A wire is cut into a few pieces in which 10 cm, 4x plus 20, 3x minus 10 are 3 consecutive pieces of a geometric progression. So they are giving you the three consecutive terms, okay? But they didn't tell you that 10x is the first term. Okay, so from here you cannot assume that a is equals to 10x. No, you cannot assume that, because they say these three are 3 consecutive terms. They never say it's the first term, starting from the first term. Okay, so what they're asking here, question A, find the longest piece if 10x is the second longest term. Okay, so that means, you see here, they are cutting the wire, correct? It can be from the shortest length to the longest length, or from the longest length to the shortest length, correct? But since they are telling you here that 10x is the second longest, so in other words, they are arranging from the longest to the shortest, correct? Because the second longest is 10x. So in other words, they are arranging from the longest to the shortest. So if 10x is the second longest, the longest should be a value, correct? So this question, they make it so complicated, right? They are actually just asking you to find the a value, because that is the longest term. So but before that, to find the a value, you can just use the form an equation using this, because they say 10x equals to the second longest. So that means t2 should be 10x, right? The second term is equivalent to 10x. But if you notice one thing, you're finding for a value. Okay, this is what you're finding for. The n value you already know, because it's 2 here, correct? So n equals to 2. But you don't know what is your r value, the common ratio. Because why? Even if you do, for example, you take 4x plus 20 divided by 10x, okay, to find your common ratio, you are still finding in terms of x. Okay, you cannot eliminate the x. And the question didn't say that they want you to leave your answer in terms of x. So because of that, we must first find out what is the x value. Okay, we must find out what is the x value. And to find out the x value, we are going to use the three consecutive sequence here. Okay, so that means we can assume that r1 is equals to r2. So what is r1? r1 is 4x plus 20 divided by 10x, okay, the first 2 terms there. And then r2, we can say 3x minus 10 equals to, divided by 4x plus 20. So I'm going to cross multiply. So I should get 4x plus 20 square equals to 10x times 3x minus 10. So from here, your answer should be, I'm going to expand this, 16x square plus 160x plus 400 equals to 30x square minus 100. Okay, so I'm going to put them all together. I'm shifting everything to the right. So I should get 30 minus 16 is 14x square. Here should have an x, negative 100x. So here should be negative 260x minus 400 equals to 0. Okay, so you can straight away factorize this. You should get 2 brackets So you should get x minus 20 and 7x plus 10. Okay, you just type into your calculator, you should get the answer. And so in other words, x is equals to 20, or x can also be equal to negative 10 over x. But here's the thing, this one is rejected. Why? Because if x is equals to negative value, when you substitute into the x value here, you'll get a negative length. Okay, so it's not possible for you to have a negative length. So that's why the negative x value would be rejected. So in other words, x value is equals to 20. Okay, so now you can find your r value. So what's your r value? R value equals to 4x plus 20 over 10x, correct? So you already found your x, your x value. So x equals to 20. So 4 times 20 plus 20 over 10 times 20. So you should get 80 plus 20 is 100 divided by 200. Answer is 1 over 2, or I can say 0.5. Okay, so let me just... Okay, so now you want to find the a value. So just now we already formed the Tn, correct? So Tn is equals, T2, because it's a second term, is equals to 10x, correct? So we're going to substitute. What's the Tn formula? AR power n minus 1 equals to 10x, correct? So A is what you're finding for. R is 0.5. N value is 2 minus 1 equals to 10. So what is x again? X is 20. Okay, so you want to find A value. So A value equals to 200 divided by 2 minus 1 is 1, 0.5. So just divide by 0.5. Answer is 400 cm. So this is your A, the value of A. So the longest wire, in other words, if you want to write longest piece is 400 cm. Okay, you can write this. Question B. If the wire is cut into sum of infinity pieces, find the maximum length of the wire in meter. So now they are just saying sum of infinity. So you just have to substitute into the sum of infinity formula. So A is equals to 400 divided by 1 minus R. R is 0.5. So 1 minus 0.5 is also 0.5. So you get 800 cm. Since they want in meters, so this is equivalent to 8 meters. The diagram on the right shows the pattern of a spider web. Okay, so the perimeter of each semicircle, so they giving you they are counting in terms of semicircle, follows geometric progression with the smallest radius RCM, and each subsequent radius increases 40%. So it's from a small radius to a larger radius, but remember it's all semicircle. Okay, so form the first three terms for perimeter of the semicircle in terms of R. So question 1, they want you to find the perimeter, the sequence of first three terms of the perimeter. So we are going to find, okay, so when n equals to 1, the first term, right, what is the radius? Radius equals to R, the first one. Okay, and then the second term, radius is equals to 40%, correct? So 40% increase, so that means 1.4%, 1.4 R. Why? Because you're going to take 100% plus 40%. Okay, because you're increasing times the radius, the previous radius. So in other words, you get 1.4 R. Okay, so this is your second term radius. And then the third term is 1.4 of the previous term. So in other words, is 1.4 square R. Okay, so they want you to find perimeter. So perimeter is equals to 2 pi R. But remember, they are saying semicircle, correct? So you have to divide by 2. Okay, So this one is 2 pi 1.4 r divided by 2, and the last one here should be 2 pi 1.4 square r divided by 2. So you can actually simplify all of this. So you should get pi r, that's the first term for perimeter, and then you should get 1.4 pi r, and then the last one 1.4 square. You can make it into a, calculate the 1.4 square. You should get 1.96 pi r. Okay, so this is your sequence, the perimeter sequence. Okay, so this is all in terms of cm, by the way. Is it in cm? Yes, in cm. So cm, cm, cm. Okay, this is question A. Now question B. Question B, find the total length of semicircle in meters. Okay, in meters. If the spider web has 15 semicircle, each radius is 2 cm. So in other words, they want you to find the sum, right? The total length. So that means sum of the 15 terms. Okay, but before that, we have to know what's the A value. Since they said radius equals to 2 cm, so A value should be equals to pi r, right? So pi times 2 equals to 2 pi cm. Okay, and then you want to find the common ratio. Common ratio should be equals to 1.4 pi r divided by divided by pi r. So here cut, you should get 1.4. Oh, no cm. This is common ratio. So now you can substitute into your formula. So since modulus r is more than 1, we can use the first formula of that, the sum of ratio. So it's a r power n minus 1 over r minus 1. So A is 2 pi, r is 1.4 power 15 minus 1 divided by 1.4 minus 1. So you count this, just type into your calculator, you should get 2427.95 cm. But one thing, they said give your answer in meters. So you change this into meters and you round it up, you should get 24.28 meters. Okay, so this is how you solve this kind of questions. So that is all for this video. We have covered most of the major important questions for geometric progression, and in the previous video I've covered arithmetic progression. So we are basically done with chapter 5. Alright, so if you find this useful, of course don't forget to like, subscribe, share, whatever you guys do. I'm not very familiar with this, but it means a lot if you guys can help me with that, and I really appreciate it. So that is all for today, and I hope to see you guys on my next video. Take care. Bye bye.